Welcome back to the lab, guys. So I found this Traynor TS-15 amplifier lying out at the foot of somebody's driveway with a sign on it saying free. So I decided to pick it up. Now it looks like it's seen better days, but I thought this would make a great little project for repair and refurbishment. I'm not a guitar player myself. I don't really have any use for something like this, but my son is. And he was talking about getting himself a small portable amplifier. Like he's got something he calls a 5150 stack, and he says it's not very portable. He just uses it at home, and even though I think it's really a stage amplifier. But anyway, that's all, neither here nor there. But this thing looks like somebody pulled out the speakers out of it for one thing or another, and then put these gems in its place. And look at this, they put a port in the front of it, even though it's an open back amplifier. So whoever did this, I'm just assuming they're either joking or they didn't know what they were doing. So I just wanted to have a look at it. It's got all these things written on it. Here we go. The Doors and AC/DC, Metallica, and a bunch of others. So it needs some cosmetic improvements. But another thing I found neat about it is it's actually built in Toronto by Yorkville Sound. Now, Yorkville Sound, they are affiliated with Long & McQuaid, which is a huge, big music retail outlet up here in Canada. And so this is it. It comes complete with leaves inside. So I'm just gonna today. What I'm just gonna do is I'm just gonna tear it apart. I'm gonna have to replace those speakers. He's got two 4-ohm speakers there in parallel, which is probably a little bit more than this amplifier could sustain as far as impedance is concerned. So it may even have a blown up output stage. But yeah, I'm gonna have to buy new speakers for it, and generally fix it up. I'll take off all the hardware off it and clean off that vinyl. But today what I'm going to do is I'm going to pull out the amplifier and have a look at that and see if it actually works. And well, let's do that, and we'll come back when I've got it mostly pulled out. All right, we've pulled the amplifier chassis out. It's pretty easy with these things. There's usually 4 screws, 2 at the top, 2 at the back. That's the way the last Fender amplifier I worked on was also installed that same way. And then this whole chassis just pulls right out. It's a big beefy transformer here. Does that look like a 15 VA transformer? Anyway, so I don't like, look at this. Look at the way these wires are just being squished to heck down there. There's got to be a better way to do it than that. Maybe what I'll do also is I'll maybe drill a hole in there and then a hole here and a hole here. Kind of bring this wiring up. I don't like that. Don't like that. All right, so now I'm going to pull this PCB off. Now, the way you normally do that is you have to remove all these nuts, remove the knobs, remove that screw, and then it should just pop right out. All right, we got the circuit board out, and oh boy, is it look at the construction on this. This is terrible. I wouldn't be tempted to buy anything from Yorkville Sound. Entirely due to what I'm seeing here. This is just, it's just the worst ever. Take that off there. And look at the way the transistors are mounted. Like they're just flapping around willy-nilly in the breeze. Oh boy. Capacitors are the same. Look at this pot, the way it's attached. These little twisted wires coming up, not even properly trimmed. Man, this is a mess. There's one little IC in it. The rest of it is transistors. These ones here are connected up via these little Molex connectors. And these capacitors, Marcom. I don't know if they're a good brand or not, but they don't look like they've leaked. I guess I could test them. Here's the bridge rectifier. Resistor for the LED, which is, look at the way that's mounted too. Like, boy. Little wooden standoffs for the, are they wooden? Oh no, they're phenolic. The knobs came off pretty easy, which is good because that can sometimes be a destructive process. So that was nice that they obligingly came off. And yeah, so I'll hook this up. We'll put a signal in it, and I'll put a load on it using some resistors that I have. And we'll see if it actually produces anything. 2 inputs there. And they just mix straightly into the same thing. So one's not a high or a low, they're both the same. And into this IC, it's probably a little op amp. Let me have a look. It's a TL071 op amp, and the transistors are all different. We can look those up on the schematic if necessary. But yeah, so that's it. So yeah. Volume, bass, treble, master. Now the master switch here looks like it just switches these resistors in series with the speakers. I haven't really taken a good look at the schematic myself. I guess I better do that before I hook things up. All right, let me think about how I'm going to hook all this up, and I'll come right back. Okay, folks. So I've got the function generator coming in here, and I've got that set up right now for 400 hertz at 10 millivolts RMS. I've got the output is going to these two 10 ohm resistors in parallel, so it's 5 ohms, and I've got an oscilloscope attached up to that. So let's get the oscilloscope up on the screen, and we're powered on, I believe. Yeah, the LED's on, and let's just start turning up the volume knob here, and there we go. It looks like we're picking up a little bit of hum too. To be expected. I guess I should be thoroughly shielded all the way, but that's okay. We're just playing around here right now. So it looks like we're getting about 3 volts maximum volume. We've got 3 volts RMS coming out of it, and it's not a lot of watts. Maybe what, 2.5 watts into 4 ohms. So if we keep on, we're beginning to get a distortion here at only 3.5 volts coming out of it. As we get to distort badly. Getting about, most guitars like a little distortion. So let's say we got 4 volts RMS coming out of the thing. That's nowhere near 15 watts. So the peak to peak is 11. And we turn down the volume. Yeah, so that's the best we're getting is about 9 volts peak to peak, or 3 volts RMS. That's our 16 millivolt input. And what do the tone controls do here? Oh, that turns it into an oscillator if I turn up the high frequency too much. Let's see if I bring down the volume. Yeah. There's got to be something wrong there. But at least it's working. At least it's producing something out. Here, this one here is the bass. When I turn up the bass, the treble goes down. That's odd. It shouldn't really affect the treble. When I turn up the treble, it turns into an oscillator. So we're oscillating at about 4 kilohertz there. Nice. And what happens if we increase the frequency here? Let's put it up to 1 kilohertz here. So, yeah, it immediately turns into an oscillator at anything over a certain level. So I should look at why that's happening. But here, we're getting a little bit more out of it before distortion. We're getting 4 volts RMS. So if I'm not mistaken, into 5 ohms, you're talking about 3 watts, somewhere about there. And 11 volts peak, so that'd be at 24 watts peak. Okay, let's go up to 2 kilohertz. Oh, we're getting much more out of it now. We're beginning to clip up around about 9 volts RMS. We changed the amplitude on the function generator. It's a little bit nicer to change. So we're beginning to clip there. So yeah, let's call it 9 volts RMS. So that is into 5 ohms. That's about 16 watts. So we're getting there. I guess it is a 15 watt amplifier if you look over a full spectrum. I don't know how much in around 2 kilohertz or above you'll actually get out of a guitar. Let's see what go up to 3 kilohertz. It's 4 kilohertz, 5 kilohertz. It seems to be hot on the treble side. It doesn't oscillate at this frequency. Let's bring the input way down. Put it at 10 millivolts. And we'll turn up the treble. Okay, got a lot of headroom there. It's topping out around about 15 watts or so. Alright, let's increase the frequency a little bit more. It begins to roll off here at around about 10 kilohertz. Yeah. Frequency response is best in between about 10 kilohertz and 5 kilohertz. It rolls off really bad down here. Too much treble and it begins to oscillate. So I think this is worth investigating a little bit further. I think I'll go ahead and spend the money on a couple of 8 ohm 8-inch speakers to go into that cabinet, and we'll try to get this thing figured out. So the next step would be to trace through here to see where it's beginning to distort and see if there's anything we can do to alleviate that problem. It could be like a bad capacitor, like maybe that little electrolytic there, I don't know. But we'd have to try and find out where the problem starts to come in and what we can do to mitigate it. It may just be that that's the way this amplifier is. It doesn't look like a great design, but there you go. I see them listed on eBay going for $200. So, or not eBay, Kijiji, which is our local thing here in Canada, buy and sell. It's owned by eBay, but it's not eBay. We have verified that it's working, more or less. We have verified that it's not working great, that it has a very narrow frequency response, and it has some issues that may be inherent in it. I don't know. Like I said, we'll have to get into it a little bit more. So the next episode on this, what I'm probably going to do is trace the signal through with the oscilloscope to see where it is going to start all this shenanigans. I'm guessing it's going to be around about here. But the way this is designed, that changing this can affect this here a little bit too. So, and finally, I guess we're going to wrap it up with if we can get it all fixed up, we'll put some speakers in it. We'll refurbish the case and everything like that. I don't know if you guys, let me know if you guys are interested in seeing my steps about refurbishing the cabinet and cleaning it up. Personally, I find that's very boring, but you guys might be different, and I have to do it anyway, so I could do it on camera if you really want. And then we'll put the whole thing back together again and see if my son wants it. If he doesn't, I'll put it on Kijiji for $100. All right, so here's the schematic for this amplifier here. So here are the inputs going through those 10K resistors. Here's a little bit of input protection here with these diodes into the TL071. Kind of a bit of an unusual arrangement here, but I suppose it works. I guess that 47 picofarads there is to help prevent some oscillations, which seem to be happening anyway. So the oscillations happen when this is turned up. I'm guessing that would be in that direction. Okay, then it goes over here to this differential pair, which feeds into this pair of complementary transistors here, which feed into this pair of complementary transistors, these Darlington pairs here. TIP100, TIP105. It's a very basic design, not much to it. So I guess what I'll have to do is just go in and probe along and see where the oscillations start when this thing gets turned, and then see what we can do about it. Now also this 100 nanofarad here, that may be responsible for the poor low-end performance of it. So maybe increasing this, that might help a little bit with the low-end response. Fairly basic, but we have a schematic so we can work through it and find out exactly what we can do to mitigate that horrible performance. And once we do that, I'll order up some speakers for it and we'll rebuild the thing. Okay, well, thanks guys for joining me today. I really appreciate it. Leave a like and subscribe if you like what you found today, and you can hit the super thanks if you want to help support the channel, or there's a link to PayPal. Catch you in the next one, guys. Thank you very much. Bye.